Hello everyone, this is the third part for this hardest sat math questions that we're doing every day. I couldn't make a video yesterday. I had some work. I was catching up on that, which is no excuse because I have to do this every single day. But yeah, I'll try not to skip another day now. But here's question 6. So let's just start with it. If you haven't seen the last two parts, we've done these questions which were pretty interesting. So if you want to check those out, you can click the description and find it there. Alright, so this is the first question. You can take a look and yeah, I'll start solving this myself. So basically the question says let f of x be ax squared and g of x be bx raised to 4 for any value of x, alright? If a and b are positive constants, how many values of x is f of x equals to g of x? Okay. Alright, immediately I can see that we're setting this equal to one another. So let's just do that. I'm going to say that a of x squared is equal to b of x squared raised to 4. Right, we'll start with that. Also, excuse my voice. For some reason, I have a sore throat, even though it's not that cold. But yeah. Anyways, so now what we can do is we can solve it for x. So yeah, x is being divided, multiplied over here. We're going to divide it on the other side. We're going to get a is equal to b times x raised to 4 divided by x squared. We'll cut this and then we'll be left with this. And what we can then do is we can write x squared is equal to a over b, and then you can take an under root. That's going to give us a over b, like that. Okay, so because we took an under root ourselves, we're going to have plus minus, right? So these are going to give us two values of x. That makes sense. Okay, and what else can we do? Am I missing something? Yeah, I think so. Wait. What if we solved it a different way? What if we just... Oh, I see. We're going to take this on the other side. It's going to subtract then from a squared. So a squared minus bx raised to 4 equals 0. We can take x squared common. That's going to leave us with a minus bx raised to 2. Right? That's going to give us equal to 0. Yeah, I left one of the equations, which probably messed everything up. But now we can set this whole thing, and that's going to give us this. But we also have to set x raised to 2 equal to 0, which is then going to give x equals to 0. So that means we actually have one answer as x equals 0, and then we have two answers from this over here. So it could be x is plus under root a by 3, and it could also be x equals minus under root a by b. So I guess they're asking us to find how many values of x satisfy this equation. If we're talking about that, then it's going to be 1 and then 2 and 3. So it should be 3. Let me just write that down. Yeah, so the answer should be D. Alright, here is question number 7. Let a and b be numbers such that a is greater than 30 and less than 40. Okay. And b is greater than 50 and less than 70. Alright, so for b we have a 20 numbers range. For a we have a 10 number range between 30 and 40. Yeah, okay. Which of the following represents all possible values of a minus b? Alright. Okay, so what can we do? Okay, this is quite an interesting question. So immediately what I'm thinking is we need to find the minimum value, right? Which is going to be a minus b. And then we also need to find this maximum value. Now to find the minimum value, what we'll have to do is we'll have to subtract we'll do minimum of a, which is going to be 30 in this case. So we'll do 30 minus the maximum of b, which will be 70, right? And that's gonna give us minus 40. Yeah, I think that's what's gonna come over here. And then to find the maximum of this equation, what we can do is we'll do the opposite, right? So we'll do maximum of a, which is going to be 40, minus minimum of b, which is going to be 50, and that's going to give us minus 10. So it's going to be minus 10 over here. I think the answer is then going to be b. Yeah. This was interesting. I guess in these kind of questions it's not too working heavy. You just need to understand the question. If you understand it, you're gonna get it right. If not, then you can't. But yeah, that's pretty much it. We'll move on to the third question. This is what we have in the equation shown above: x, y, and 0 positive integers. All of the following could be a possible value of y, except what? Okay. So, alright, I don't know if this is correct, but right now immediately I'm thinking this added together should give us a whole number, right? It shouldn't be a fraction. So let's just see if I can figure it out from there. So if we choose no, maybe not actually. I think let's just rewrite this equation for y, and maybe there is some kind of condition where we could factor it out and see if a certain number doesn't work. So let's just rewrite for y first. So what I'll do is we'll do y over 12 is equal to z minus x over 3, and then we'll multiply it by 12. So we'll write y is equal to 12z minus 4x. Yeah, that's what we have. Yeah, like that. So now what we can do is, what can y not be? Oh, alright. So it's a positive integer. So we have to make sure that when we subtract 4x from it, we always get a positive number. Okay, and let's make our life a bit easier. We'll factor out 4 from here, and that's going to leave us with 3z minus x, right? So now 3z minus x, it should be equivalent to a positive number. No, that. Okay, so alright, so because this also has to be an integer, right? Y has to be an integer. So I guess we can say that y will have to be a multiple of 4, because this 4 eventually has to go and divide on the other side. And if it's not a multiple of 4, we're gonna get a fraction, right? And we don't really want that. We wanted to like cut with the denominator, like something, like that. And if you look at the option choices, this is a multiple of 4, so is 8, so is 12, and so is 20. The only one that's not a multiple of 4 is 6, so it's probably going to be the answer. And yeah, that's pretty much it. Okay, let's move on to the fourth question. So basically the question says under root 72 plus under root 72 equals m under root n. In the equation above, m and n are integers such that m is greater than n. Which of the following is the value of m? Alright, let me just get my calculator for this because I usually just figure it out from my calculator. Let me see if that's possible here. I'll just do under root 72 plus under root 72. And that gives us, so my calculator just gave me 12 under root 2. Now they're saying that m is greater than n. Yeah, that's true. So it's just going to be 12. Like, that wasn't hard. I guess if you're solving it by hand, it probably is, but I just use the calculator for these questions. Yeah. So yeah, that is pretty much it. I really don't see why you would actually need to learn the other way to do this, which is probably the harder way, if you can exactly just solve it with a calculator. Let's just move on to the next question. So this is the next question over here. The table shows some values for the function n. If function n of t is equal to k times 2 raised to minus at for positive constants k and a, what is the value of a? Alright, so we have an exponential function over here. To be precise, it's negative. It will be going downwards. Yeah, so what is the value of a? Alright, so I guess we'll first of all just substitute it in for this value over here. So t is 0 and n of t is 128. We'll do that. So we have n of t is equal to k times 2 minus raised to minus 80, right? We'll substitute for n of t as 128, and our k is going to stay as it is, and 2 is going to be raised to minus a times 0. Now since it's minus a times 0, it doesn't really matter, a is going to cancel out, and we're going to be left with, because anything raised to 0 is 1, we're going to be left with k times 1 is equal to 128. And so the value for k we're going to get is 128, right? This is what we know so far. Yeah, so now for t equals 1, we have all the variables except a, so we'll find out a from there. So we'll just write n is equal to 16 for t equals 1, and then we have k as 128, and we also have, yeah, so we have times 2 raised to minus a, and then that's it, right? Because it's multiplying with 1, we don't really need to write that down. And this is what we have. And then we'll divide 128 on the other side. That's going to give us 16 over 128 is equal to 2 raised to minus a, right? And what can we do then? Yeah, we'll just divide it. That's going to give us 16 1 times, 16 8 times. And we'll be left with 1 by 8 is equal to 2 raised to minus a. So usually in SAT, usually in questions like this in SAT, what you have to do is you have to put it the same base, and then you can equate the exponents. So I'm going to try and see if I can do that. So we can do 1 by 2 raised to 3, right? Because 8 is 2 cubed. And then we'll write this as minus a. And yeah, that's pretty much it again. So what you'll do is you'll bring it to the numerator, and once you do that, the exponent's sign is going to flip, right? So you're going to be left with 2 raised to minus 3 is equal to 2 raised to minus a. And so you can now equate the exponents over here, which will then become this is equal to this, right? So we can write this down as minus 3 is equal to minus a. And so once you cancel out the minus signs, you'll be left with 3 equals a. So we had to find the value of a, yeah, it's going to be e over here. This, I wouldn't call this question necessarily hard. I guess it's just working intensive, but still there are harder questions on the SAT. I wouldn't really call it too hard. But anyways, these are the 5 questions we did for today. Tomorrow we'll be doing this graph one, which seems interesting. But yeah, if you're liking this series, hit the like, subscribe, all that stuff. And I have mentioned this before as well. I'm doing this to prepare for my SAT, and if you're interested in doing the same, you guys can tag along, and yeah, we'll try to score a good score. But yeah, that's pretty much it from my end. Have a great day.